Okay, so we will be doing question 8.4 now. Right, so 8.4 telling you that there are two persons who are choosing simultaneously how many hours to spend on doing a loan together. And the average benefit for each of the person is equal to 10 minus Li plus Lj on 2, where so this is the average benefit of person I, and Li is the number of hours to spend by person I, and Lj is the number of hours that is chosen to spend by the neighbor, which is person 2. Okay. The average cost for each of the person is equal to 4. So for each of the hour they choose to spend on doing the loan, it will cost them 4. And part A of the question asking you to find the Nash equilibrium. Okay. Now in order to find the Nash equilibrium, each of the person will be choosing how many hours to spend on doing the loan, and they will be choosing simultaneously in order to maximize their net benefit. Okay, so basically we are doing the maximization problem for each of the person and then solving for the values of L simultaneously. Right, so we will be doing for person 1 first. So person 1 will be maximizing his net benefit by choosing how many hours to spend, which is basically L1. So what is his net payoff, like net benefit, which is so that basically is the total benefit minus the total cost. Now total benefit for person 1 will be equal to the average benefit for person 1, which is 10 minus L1 plus L2 on 2. This is the average benefit. In order to find the total benefit, you will have to multiply by the total amount, like the total number of hours chosen to spend by person 1. So that's the total benefit and minus the total cost. Now the average cost equal to 4. Total cost will be the average cost multiplied by the number of hours chosen to spend. Okay, so now person 1 will be choosing L1 to maximize this. So we're going to be doing the first order condition where we differentiate the net benefit with respect to L1 and make it equal to 0. Now if I differentiate the total benefit, the net benefit, which is this thing here, this is the net benefit. Okay, so if I differentiate that with respect to L1, I'll get 10 minus 2L1 plus L2 on 2 minus 4, and that will be equal to 0. Okay, so I will get 6 minus 2L1 plus L2 on 2 equal to 0. Now remember, the thing I want to find is L1, so I would like to express L1 as a subject, and that will give me L1 equal to, so if I move everything that doesn't include L1 to the right hand side of the equation, I will get 6 plus L2 on 2, and I want to divide everything by 2 because I want to find L1. So if I simplify this, I will get 3 plus L2 on 4. Okay, now this is called the best response function of firm 1 or of person 1. So that basically means this equation here, this function here, telling you how many hours the person 1 will be choosing given the number of hours chosen by person 2 in order to maximize his net payoff, his net benefit. So by knowing the values of L2, this person 1 here will be choosing L1 according to this function in order to be maximizing the net benefit. Okay, so that's equal to the best response function of person 1. So we'll be doing the same thing for person 2. Now person 2 again will be maximizing his net payoff. So maximize the total benefit minus the total cost for person 2. Now remember, will be equal to the average benefit for person 2. That will be equal to 10 minus L2 plus L1 on 2 multiplied by the total numbers of hours chosen by person 2 minus 4 L2. And this person is choosing L2. Okay. So again, first order condition is 10. So if I differentiate the net payoff, the net benefit with respect to L2, I get 10 minus 2L2 plus L1 on 2 minus 4. I want to make it equal to 0. Okay. So again, I will have 6 minus 2L2 plus L1 on 2 equal to 0. Now again, the thing I want to find is L2, so I would like to express L2 as a subject. So L2 will be equal to, again, that will be similar to L1, so that will be equal to 3 plus L1 on 2. And this is called the best response function of person 2. So that basically, knowing the values of L1 chosen by the first person, I will be choosing the number of hours according to this function over here in order to be maximizing my net payoff. Okay, so that's the reason why this is called the best response function, because I am choosing my numbers of hours depending on the number of hours chosen by the other person. Okay, so now in order to find the Nash equilibrium, we will just have to find the values of L1 and L2 that are chosen by person 1 and 2. So I'll call this is the first equation and this is the second equation. Okay. Now by looking at the first and the second equation, I know that they are symmetric. So due to symmetry, I know that L1 will be equal to L2. So that the optimal L1 will be equal to optimal L2. Basically mean person 1 and 2 will be choosing exactly the same amount of hours they want to spend on doing the loan in order to be maximizing their net payoff. Now, if you are looking at two equations and don't really see that they are symmetric, you can still solve for the values of L1 and L2, even though they're not equal to each other. Okay, so easiest way is to substitute one equation into another equation. You have two equations, two variables, very straightforward to find the values of L1 and L2. Okay, so now in this case, because I know they are symmetric equations, I know that L1 is going to be equal to L2 in the equilibrium, and that will make things easier. Okay, so knowing L1 equal to L2, using, say, I'll use the first equation, you can use the second equation, that will just give you the same answers anyway. So using the first equation, I will get L1 equal to 3 plus L2 on 2, and L2 which is equal to L1. So I'll sub L1 in there, and therefore, sorry, that should be 4, isn't it? Okay. And this should be 4. Okay. Therefore 3 on 4 of L1 will be equal to 3, and therefore L1 will be equal to 4. Alright, so this is L1 star because this is the optimal L1, and I know that it will be equal to L2 star as well. So basically, in the Nash equilibrium, each person will be choosing to spend 4 hours doing the loan in order to maximize their net benefit. Okay, so Nash equilibrium is L1 equal to L2 equal to 4. Okay, I put the star there to indicate that so they are the optimal number of hours. Nothing special about it. Okay, now part B, asking you to draw the best response functions on a diagram and indicate the Nash equilibrium. Okay, so I will just rewrite the best response function we found from part A. The best response function for person 1 is L1 equal to 3 plus L2 on 4, and the best response function for person 2 is L2 equal to 3 plus L1 on 4. Okay, now I want to draw them on a graph. Right, so I'll just draw a graph here on the side. Okay, so I will have L2 say on the vertical and L1 on a horizontal. Okay, I'll draw the best response function for person 1 first. Now I have L2 on the vertical and L1 on the horizontal, so it will be easier to rearrange the best response function of person 1 to make L2 as a subject, because I have L2 on the vertical. Okay, so if I rearrange this equation over here, I will get L2 equal to 4L1 minus 3. Okay, so I have now a function with L2 as a subject, so that will be easier for me to draw on the graph. Okay, so I know that I got the vertical intercept equal to -3 and the slope equal to 4. Okay, so I'll just pick the points to say if L2 equal to 0, L1 will be equal, oops, sorry, so I should so this, right, so you're gonna need to rearrange it. So I should get rid of it here. Okay, so I just draw the best response function for for person 1 first. I'll just pick the random point. Basically by looking at that, I know it is a straight line. Okay, with the slope. So if I rearrange it, L2 will be equal to 4, L1 minus 12. Okay, so by looking at this, I know I will be having a straight line with the slope equal to 4, positive, so it is upward sloping. And in order to draw a straight line, I would need 2 points. Okay, so I'll pick L2 equal to 0. If L2 equal to 0, L1 equal to 3. So I'll say I got 3 here, first point. If I'll say if I pick L1 equal to 0, L2 will be equal to -12. Just go further down with the slope equal to 4. Okay, so you can just pick another point, whatever point, and just have a straight line upward sloping. So I'll just draw a random one, not really precise with the number, but it's okay. Okay, oops. Okay, so I will just do a line like this. So the slope equal to 4, and this is the best response function for for person 1. Okay, so I do the best response function for person 2 now. Now person 2, L2 is already a subject, so you don't need to rearrange it. By looking at the function here, you can see that it is again a straight line with the slope equal to a quarter, which is 1 on 4. Again, it's positive, so again we have an upward sloping curve with the vertical intercept equal to 3. Okay, so say somewhere here, and the slope equal to a quarter, so you know that the line will have to be flatter than the best response function for person 1, because the best response function for person 1 having the slope equal to 4, now the slope only equal to a quarter, so it has to be flatter. So I will just do a random one like this, and I'll say this is the best response function for person 2. Okay, now the intersection of best response functions for for 2 people will be the Nash equilibrium. Okay, so this here is the Nash equilibrium. Okay, so we're done. Now part C. So see asking you show on the graph that if the intercept for one of the average benefit of a person, so for one of the average benefit to fail from 10 to some smaller number, how would that change the Nash equilibrium? Okay, so I'll say the average benefit for person 1, so instead of having 10, I which is now having, for example, 8. Okay, so you can pick any random number here so long as it's smaller than 10. So I'll just pick A minus L1 plus L2 on 2. Okay, so the average benefit of person 1 is now different, and the average benefit for person 2 is still the same, which is 10 minus L1 plus L2 on 2. Okay, so given there isn't anything changed for person 2, the best response function for person 2 is still the same, whatever we found before. Okay, so best response function for person 2 is still L2 equal to 3 plus L1 on 4. Now for person 1, the average benefit is now different, so therefore the best response function will be different as well. So for person 1, again we will choose how to do the problem. Say person 1 again will be maximizing the total benefit minus the total cost, so which is the average benefit multiplied by L1 minus 4L1, and this person will be choosing L1. Okay, so we will just have the first order condition again, where is equal to A minus 2L1 plus L2 on 2 minus 4 equal to 0, and therefore it will be equal to 4 minus 2L1 plus L2 on 2 equal to 0. Therefore L1 will be equal to 2 plus L2 on 4. Okay, so looking at the new best response function for person 1, so outside you see the best response function for person 1 dash, which is the new best response function for person 1. If you compare this one to the original best response function, you see that only the only the intercept here is different. Okay, so I will be drawing this one on the graph and then see how it change. Okay, so if I rearrange this to make L2 as a subject, because I want L2 on the vertical axis, then I get L2 equal to 4L1 minus 8. Okay, so again, looking at this, it's still the straight line with the slope equal to 4, so you know that the new best response function will have to be parallel to the old one, because the slope is still equal to 4. The only thing changing is the vertical intercept here. So instead of negative 12 like before, it's now equal to negative 8. Okay, so only thing changed is the vertical intercept. The line will have to be parallel to the original line. So say if I pick L2 equal to 0, L1 will have to be equal to 2, and so the new line will be, so say 2 is here. So I know that it will be going through this point, the new best response function, and it has to be parallel to the original, to the old best response function for person 1. So we should draw a parallel to the best response function, and okay, so this is the best response function for person 1 dash. Okay, and this is gonna be the new Nash equilibrium. Okay, dash. Right, so by looking at the new Nash equilibrium, you can see that the amount of L1 and L2 are now both lower in the Nash equilibrium. So basically, both of the persons are choosing to spend less hours on doing the loan in order to be maximizing their net payoff. Um, if the average benefit of doing that for person one is now lower.